Hello children. We had seen few volumetric analysis practicals and I hope you must be thorough with the observations, calculations and the procedure of volumetric analysis. There are many practicals in our book. Please go through it thoroughly and try to practice. And if you have any problem, please you can ask. Now we'll start with our next practical, that is chromatography. I hope you're aware of it, chromatography. We are going to implement it. We're going to use it for separation. Now we'll see the principle. We'll see the introduction of chromatography. It is a sensitive technique for rapid and efficient analysis for separation of components of a mixture and purification of compounds. The principle which is involved is it is based on the differential migration of the individual components of a mixture through a stationary phase under the influence of the moving phase. Stationary phase can be porous solids like silica or alumina, and which is packed in a column or supported by a filter paper or a glass strip. Children, the moving phase can be a solvent or a gas, and which is known as eluent. If we see the different types of chromatography, so broadly we have column chromatography, TLC, that is thin layer chromatography, gas chromatography and paper chromatography. We are going to study paper chromatography. So paper chromatography is a type of partition chromatography. Now if you see here the principle, to a mixture of two immiscible liquids A and B, we have taken a mixture of immiscible liquids, that is A and B. The mixture of two immiscible liquids A and B, if a substance which is soluble in both A and B is added, then the substance added distributed itself in such a manner that the ratio of its concentration in two liquids A and B is constant at a particular temperature. Now children, here we are going to use a special absorbent paper. The moist adsorbent acts as the stationary phase and solvent as a moving phase. You can see here the diagram of our setup. This is your glass jar. Here, this is the chromatographic plate or paper, you can see. This is a glass rod to hang the paper. Pure solvent is filled till here. This is your original spot of the mixture. This is a spot of the mixture which we are supposed to separate, and the process of this putting a spot is known as loading. This is the solvent front, and these dots which you see here, or circles which you see here, these are separated spots of different colors. Now we'll see the procedure how to carry it out. So what you're going to do, you're going to take the mixture which has to be separated or analyzed, and what you're going to do, on the paper sheet you're going to put a spot, and then you're going to place that paper in a container with suitable solvent. Okay? Now as the solvent rises up, you know that due to capillary action the solvent rises up. So as the solvent rises up and the components of the mixture rise up to different rates, as it is a mixture, so each component will rise at a different rate and they get separated from one another. So see the setup, like if you see this is the paper strip. Here is the original spot of mixture. We are going to put a spot of mixture here. This is known as loading. Then we are going to place this strip in the suitable solvent container, you can say, that we have seen the glass jar, and we'll keep it. Now the way you have to keep it, that it should, the lower portion of the paper should be like such that the spot should not be in the solvent. It should be a little bit above of the solvent. Now gradually what you will see, that as the solvent rises up by the capillary action, your components according to the solubility or movement, they also rise up, and that way they get separated. Here you can find this circle A, B and C. Can you see the run of this? C till here, B till here and A till here. So this way you will get these spots. So this is the chromatographic paper. This is the original spot of the mixture, and this is the solvent front. What is solvent front? The solvent has risen till here, but the solute that is the mixture, according to the capacity of movement or the solubility, they move at different levels. So we get spot of different constituents. Now children, as you see here, the solvent is rising up. When we use such type of technique where the solvent rises up, it is known as ascending chromatography. But if the solvent is taken at the top and if it comes down, then it is known as descending chromatography. Now suppose this is a filter paper, just you assume it. So what we are going to do it? We are going to make a line here, mark here, and in the center of that line we are going to draw a spot. Like suppose we are going to draw the spot here. Can you see this spot here? And then this spot will be of that mixture which should be separated, and we are going to put it in this jar. This way we are going to place it in such manner that the spot should not dip in the solvent. You can see it here. The spot should not be in the. Then gradually what you will find, the solvent rises up. Now when you had completed this procedure, the another step is you have to find the RF value. What is RF value? RF is the retention factor, or you can say retention ratio or retention front. It is the retention factor or ratio or front. RF, how you have to calculate? It is the distance traveled by that particular solute. See, RF value will come for individual component. It is the distance traveled by the solute from original line. So where is the original line here? This is the original line here. So how we are going to calculate it? The distance traveled by that component of which we are going to take out the RF value from the starting line till it has reached. Right? So that is the distance traveled by the solute from original line divided by distance traveled by the solvent from the original line. That is this distance upon this complete distance. Can you see this line? This X. This is the solvent front that it has traveled from here to here. So how you are going to calculate the RF? RF. Distance traveled by the solute from the original line upon distance traveled by the solvent from the original line. Here, if you need to take out for each component, like component A, the RF will be A by X. A is the distance traveled by the A component upon the distance run by the solvent, that is taken as X. For B, RF will be taken as distance traveled by B component upon the solvent run, that is the distance of the solvent run. Then for C, RF for C will be C by X. So this way you are going to find the retention factor or RF value. Now children, the RF value of a different substance will be different, and it depends on certain factors like nature of substance. That what is the nature of substance? On that, nature of solvent, temperature, yes, presence of impurities. If any impurity is there, you know that there is a change in the substance. Even the boiling and melting changes, the same way the RF also changes. And quality of filter paper used. Yes, that is also very important. The which type of filter paper you had used, whether the capillary action is fast or whether it is slow. So children, this is the process of chromatography. So the complete procedure I had shown along with the calculations how you are going to do it. This one practical is there in your syllabus. And next we are going to perform one, we are going to separate a mixture. Okay, so go thoroughly through it because it carries marks, so you should know it well. And from here many viva questions are also there in your final exam, so do study well. Okay, and note it down in your rough copy as it is, and when I tell you to write in the practical, then you write. Okay, bye children.